Okay, so in this video we're going to talk about the pentose phosphate pathway and the actual reactions of the pathway, including both the oxidative and non-oxidative phases. So we'll start here with glucose 6-phosphate diverting off from the glycolytic pathway, and we're going to show it up in its straight chain form. Okay, so we start off with glucose 6-phosphate here, and you'll notice off to the right I have this little 3x bracket out here. And so what that means is that you can imagine that we're starting off with 3 glucose 6-phosphate just for the sake of calculations and like tracking stoichiometry for the whole process. Okay, so just kind of keep that in mind, and I'll be sure to remind you as we go along. But so we're starting off with glucose 6-phosphate, and the first step is catalyzed by glucose 6-phosphate dehydrogenase. So we're going to actually convert glucose 6-phosphate into 6-phosphoglucono delta lactone. So that name's kind of weird, but just as a heads up, this carbon up here, carbon number 1 of glucose 6-phosphate, that whole thing's going to come off eventually as a carbon dioxide. And the beginning of that is first oxidizing it here by making this cyclic ester. And that's actually what a lactone is. A lactone is simply an ester that's part of a ring, a cyclic ester. And it's delta specifically because the carbonyl carbon starts there. And as you go along, the first carbon attached to the carbonyl carbon is the alpha carbon. Then we got beta, gamma, and then delta. So delta is the actual carbon number 5 here, which actually connects here to make that cyclic ester. Okay, maybe more detail than was necessary, but I figured I'd mention it. And of course, the phosphate's on carbon number 6. Now, since that carbon there is oxidized, something else is reduced, and that what is reduced, it's the NADP plus being turned into NADPH. And we can see here that NADPH is involved with glutathione here. I don't want to get too crazy into these details here, but this is kind of a little bit about how NADPH plays a role as an antioxidant. So you see free radicals out here. Eventually, those are reactive oxygen species. They eventually kind of make their way into hydrogen peroxide, and hydrogen peroxide is an oxidant and can damage cells. So instead of it going through and damaging our cells and tissues, glutathione in the reduced form takes the hit, gets oxidized into the oxidized form of glutathione. That's catalyzed by glutathione peroxidase, which is an enzyme that uses selenium as a cofactor. The peroxide is now harmless water, or at least much less harmful water. And then we have NADPH go back and regenerate reduced glutathione using the glutathione reductase enzyme. Okay, we'll talk more about that in its own video, but just wanted to show that here. Also, glucose 6-phosphate dehydrogenase is a regulated enzyme, and NADPH being a product feeds back negatively on this enzyme. So a high ratio NADPH to NADP plus goes through and inhibits this enzyme's activity, right? The product inhibits it, and then the ratio is important. So a low ratio of NADPH to NADP plus activates it. So there's too much NADP plus. So more NADP plus activates the enzyme, more NADPH inhibits the enzyme. Next step, 6-phosphoglucono delta lactone is converted into 6-phosphogluconate. So we also mentioned earlier that the pathway is also called the phosphogluconate pathway. This guy's the reason why. So what's going on there? Basically at this point, this enzyme 6-phosphogluconolactone hydrolase, or also known as lactonase, takes that lactone and basically hydrolyzes that ester to get this carboxyl group ready to be ousted as a carbon dioxide. Okay, and that's what happens in this step here. So that 6-phosphogluconate is going to be oxidized to ribulose 5-phosphate, or RU5P, and so that that group there comes up, that carbon dioxide comes off here. That carboxyl group comes off as a carbon dioxide, and we oxidize this carbon here, carbon number 3 here, which becomes carbon number 2 here, to make ribulose 5-phosphate. Okay, and in that process, since we're oxidizing this molecule, something else is being reduced. NADP plus is being reduced to NADPH, And it also NADPH can be used in reductive biosynthesis to convert precursors and monomers into polymers and other biomolecules, right? So that's a reductive anabolism happening there. Okay, so that marks the end of the oxidative phase, and those steps are irreversible. Now, I mentioned that this would happen 3 times, right? So we started off with 3 glucose 6-phosphates, which are 3 6-carbon molecules. 3 of those carbons came off as carbon dioxide, because 1 for each of those 6-carbon molecules that we started with. So now you have 3 5-carbon molecules, 3 ribulose 5-phosphates. Okay, and so that was all of the oxidative phase, and now we're entering the non-oxidative phase.